There we go. Okay, so yes, hello. I'm speaking to you today in my role as chair of the task force within DVB-TM IPI working group. So the task force that is responsible for the DVB-DASH specification. Okay, so what I will cover today is an introduction to DVB-DASH, where we will cover a quick refresher on adaptive bitrate to make sure that we're all on the same page and sort of, without too much detail, but just the very quick basics. Why did DVB do a dash specification when there's a perfectly good MPEG one sitting around there as well? So this overview of DVB-DASH, what does DVB-DASH actually include? What does it cover? I'll touch on the relationship with HBBTV because they are very important in the marketplace, and also where next? What is coming up in the future? What can you look forward to in the future? Now, just because of the time we have this afternoon, as I said, I won't be going into too much detail in a lot of this, but I will be going into a bit more detail about the additions in the latest version, version 1.2.1 of the specification, of the DVB-DASH specification that Peter put up a moment ago. So, adaptive bitrate, what's it all about? So, adaptive bitrate, ABR, is about allowing the content provider to encode content at different bit rates and allowing the player to select the best version of that content based upon the piece of wet string that's between them and the content provider or the CDN out there in the internet. And it's just to also say the best version may also be dependent on other factors. It's not just bit rate. It could be the codec, could be the language, or other things. But the important point here is that the content provider makes all these versions available, and it's the player that decides which one it's going to actually play and decode. So what we have in the diagram, what I'm showing here, is the encoder on the left-hand side. This produces multiple versions of the content, and we call these representations. So each version here is a representation of the content. And the group of representations is called an adaptation set. And these names are, these terms are important if you're dealing with Dash, because they're used in a lot of places. The representations and adaptation sets and other metadata actually is all described in a media presentation description file, or an MPD, which is an XML file, and that is the entry point for the player because this is where it can decide which bits of content it's actually going to play. So each representation there, I'm showing that as different bit rates. What's also important is that the representation is split up into segments, media segments. And these are ISO-BMFF segments, and the segments are time aligned between representations within an adaptation set, so that this allows a player to switch from one representation to another seamlessly without any sort of break in the content, so that as the available bit rate or the bandwidth that it sees between itself and the content provider changes, it can easily change which representation it gets from the content provider. So MPEG, the work in MPEG on Dash was actually initiated by basically Apple and Microsoft, and it came out of Apple HLS and Microsoft Smooth Streaming, and a desire to try and produce a standard that would unify them. So what then happened was that, yeah, they produced a standard which isn't quite HLS, isn't quite smooth streaming, but it is as is typical of a lot of MPEG standards, it's large and it's complicated, and as DVB has done in other cases, it's stepped in to try and profile that down into something a bit more manageable for both players and content providers, and to aid interoperability. So this profile of MPEG DASH includes constraints, requirements, limitations, a few additions, and I'll cover what the areas where these occur, just in general, as we go through the presentation. So, what does DVB-DASH cover? What's its sort of scope? So the first thing, the place where I'll start is on the MPD, so the media presentation description file, and some basic constraints on that and the content. One of the things that MPEG did in MPEG DASH was to define the concept of profiles, which was really, really useful, and something that DVB has built on. So a profile, as the name suggests, is a sort of defined set of constraints or requirements that limit which picks and chooses which bits of the MPEG DASH specification are relevant or required. And DVB did this in the first version of the specification, of DVB DASH specification, back in 2014, and that's called the DVB 2014 profile. Profiles are identified by URN. And last year, with the update to DVB DASH, we were really imaginative and defined a DVB 2017 profile with a URN. And the reason why we had to define a new profile was so that, well, I'll go into more details later, but it's so that a player which only supports 2014 profile will know that those bits over there, it won't understand, and it should steer clear of. MPDs are XML files, and as I said, MPEG have defined lots of bells and whistles that can go in there. DVB-DASH has constrained what you can do in the MPD. So there are some elements, XML elements and XML attributes that are required, particularly where these are helpful for the player to choose between the adaptation sets and representations. And in some cases, it's put maximum numbers on some of the elements, and this is to ensure or to help player implementations again, so that you don't get stack overflows or something when a player is presented, or if a player were to be presented with a really big MPD with masses of adaptation sets in there, just wouldn't be able to cope with it. The construction of the segments as well is touched upon, and there are some things defined, such as the minimum and maximum segment duration. So how long in time can a segment last for? So the maximum time will limit the ability of a player to switch to another representation if it's having or seeing problems on the available bandwidth, or maybe it can see more available bandwidth, so it can move up to a higher bit rate. And the minimum duration is there because it then limits the amount of requests that the player does to the server, and also it can limit the load that is placed upon the server from all these devices requesting segments from it. And then lastly here is, if you think we generally deal in two types of content, live content and on-demand content. And there are different requirements for both types. So DVB-DASH tries to cater for these two use cases by placing different requirements and constraints on the MPD based upon what type of content it is, live or on demand. Now, as you would expect, and as Peter intimated in the introduction, DVB has something to say about codecs. For broadcast, of course, ever since the beginning of DVB, DVB has profiled the codecs that are used. This is particularly useful for the player to know that a codec that is signaled in the content, that it can actually decode it. So if it's supporting that codec, it knows that it means that yes, it can actually decode that content. So for the video codecs, DVB-DASH has profiles for AVC and HBBTV. It does not have a profile for MPEG-2 because it was felt that certainly even in 2014, MPEG-2 was not really very useful for IP delivery, and that if you're going to do anything, you want to use AVC to reduce the bit rate. For audio codecs, you've got more choice. We've got AC3, AC4, AAC and all its variants, MPEG-H, MPEG Surround, DTS, DTS HD, DTS LBR. Subtitles is a very important topic. DVB decided not to use the bitmap subtitle specification that's used in broadcast for the IP and for DASH. It was felt that it should move instead to XML-based subtitles, and it chose to use a profile defined by EBU called EBU TTD. This what it also allows for is the use of downloadable fonts. So there is a font that's resident, which is okay for most Western Latin-based languages. Western Europe Latin-based languages, but you might need to use a downloadable font if you need to use some other characters. Content protection is a very important topic for a number of people. DVB has never selected a content protection system. In broadcast, it never did that. But it does provide the hooks and tools that can be used to implement a content protection system or content access system, a CAS. So for DVB-DASH, we don't specify a DRM, but we do reference another MPEG specification called the Common Encryption specification, which defines how content is encrypted and how the license metadata can be carried. So this is similar to, for the broadcast case, to DVB defining CSA and the ECMs and EMMs. MPEG Common Encryption is not as large a specification as MPEG DASH, but there are still a few options in there. DVB requires players to support the AES-128 CTR encryption mode. So that's sort of a base from which you can build your content protection system and that the DRM can use. Key rotation is possible, so that's going to be particularly useful for live services, not anticipated to be used for on-demand. and that typically that content has got a single key. But for live 24/7 services, then you probably want to use that. The DRM metadata, which could carry the license or the URL of the license or other metadata, can be carried either in the media segments themselves or in the MPD. So carrying it in the MPD has advantages for the player. It enables it to set up the DRM prior to starting to play the content. Whereas if it's only in the media segments, then it has to retrieve the content before it can then work out, do I have the rights to play this content? And if you're doing a live service, then maybe putting it in the media segments would be better. And one limitation or requirement that DVB-DASH puts on the content is all representations within an adaptation set must use the same encryption key, so that when the player switches to a different representation, either higher bitrate or lower bitrate, it doesn't need to do a new license acquisition. It knows it will be able to play it, and it's got the key already. DVB-DASH, well, MPEG has defined the concept of events, and DVB-DASH has taken that up. So events can be carried either in the MPD or in media segments again, so similar to the DRM metadata case, and depending what type of event they are as to where you might want to put them. DVB has defined 4 different event types. So MPEG DASH has defined how you carry events, but not what the events are. DVB has defined these 4 different event types. So you can have application messages, so sort of equivalent to DSMCC stream events. Some opaque block, that will be passed up to the application that's running. The event can trigger an MPD update in the player. Obviously, that wouldn't really be carried in the MPD itself. That's more likely to be in the media segment. So if and when the MPD is updated, then it means the player doesn't have to poll for a new MPD. It can be triggered to do that update. There's the equivalent to AIT for launching applications. So the AIT is defined in another DVB specification, TS102809. And you can carry this AIT, again, either in the MPD or the media segment. So it could be, like, for instance, an HBBTV application. And that provides the URL of the application, doesn't carry the application itself. And then you've got the equivalent to EIT for program metadata. Again, particularly useful for live. DVB generally defines bits on the wire. If you think of DVB-T, DVB-C, DVB-S, GBS, they are all sort of like bits on the wire modulation signaling. DVB-DASH goes further than that and defines actual player behavior. This is to help content providers know that the content will be playable on a DVB-DASH player. So there are some mandatory requirements for players, as well as some optional ones and guidelines. DVB-DASH, as Peter mentioned, references TS101154 for the codec profiles. And I've already mentioned which codecs those are. Well, important point here is no codec is mandatory in DVB-DASH. That will be that's left up to other specifications to require which ones. So you have to be a little bit careful as a content provider, unfortunately. But players supporting HD have to support a list of specific resolutions. So for whether you're using ABC or HBBC, then you know that if you use this resolution and the player supports that codec, then it will be able to display that resolution. And likewise for UHD, there's another set of resolutions that players have to support. You can use other resolutions, but there's no guarantee that the player will be able to present it quite as you intended, perhaps. Another important point that I've sort of alluded to already really is that players have to support seamless switching between representations, although there are certain limits to this. So when you're doing a switch up and down in bit rate from one representation to another, then you have to do that seamlessly such that the user doesn't see the join. There's no sort of black flash or gap in the content presentation. So for instance, one of the limitations there is that you've got to stay, the content has to be the same video frame rate family. So you've got to stay within the 25 Hertz family or the 30 Hertz family. You can't have representations that change the frame rate family and expect a player to be able to seamlessly present a jump between them. Players have to be resilient to certain errors in the network. So if something goes maybe a little bit wrong somewhere, a server falls over, then players have to have some backup behavior here. For instance, going to using alternative DNS records, using a different base URL for where they retrieve segments from. And players have to be able to report metrics back to the content provider. So for instance, if there's a network error, like it sees us unable to contact a server, then has to be able to report that. Not all players would do it, but they have to be able to. So I've already touched upon some requirements on content, but we also have in the DVB-DASH specification some guidelines on how to put together the content that's suitable for a DVB-DASH player. So the content guidelines cover like the video resolution choices. Basically, choose one from the lists I've mentioned already. Preferably don't stay outside them. Some guidance on audio codec parameters to choose, particularly about NGA encoding and signaling. Some guidance on how to encode subtitles. If you're running a 24/7 live service, then retaining lip sync and AV sync over that time can be challenging with Dash. So there's some guidance on how to ensure that players can keep lip sync, and also there's some guidance on how to use the temporal layers for HFR, and I'll come on to HFR in more detail in a minute. Then in the latest version of DVB-DASH, so TS 103.285 version 121, we cover a number of things here. There's some bug fixes for the old 2014 profile, which unfortunately were found. So those have been fixed, and there's if those people interested, there's a list of changes in the annex, so that people who only want to support the 2014 profile, then you can still do so. You don't have to support anything that's in the 2017 profile. There's a better definition of the video codec profiles. Before it was a little bit broken, perhaps. But now we are referring to TS 11154, where the codecs are much better defined. One of the main impetuses behind doing the 2017 update was the addition of HDR, HFR, and NGA. So the definition of those codecs and the new signaling required. And some of those changes required us to define this new 2017 profile, and I'll go into that in a moment in a bit more detail. So moving on to those additions, HDR, HFR, NGA. So touching on HDR, DVB-DASH follows the codecs that are in TS 1154 for audio and video, that is. So 11154 added HDR, and they added two variants, HLG10 and PQ10. So looking at HLG10 first, any adaptation set containing video with HLG10 has to be signaled with what are called essential property descriptors, with the color primaries, matrix coefficients, and transfer characteristics for 2020. and a supplemental property descriptor with the transfer characteristics for BT2100 for the HLG system. So essential property descriptors are ones that the player must support, else don't try and play this content. Supplemental property descriptors are ones that it should support, but even if it can't, it can play it, but it would be better if it did. So you would use these to, as part of the selection, to find the best adaptation set to play. There is a sort of a concession here that if the content provider knows that that player supports BT2020, then it can provide that player with an MPD that only uses the 2014 DVB profile, and it omits the essential property descriptors that I mentioned up above. So if there's a player in the market, and there are a number of players in the market that support HLG10, but they were only designed to the 2014 DVB profile, then this is a way of being able to provide DVB-DASH content to them. Otherwise, if as a content provider you don't know anything about the player and what it supports, then you have to use the 2017 profile in the MPD against this adaptation set, and you have to use the essential property descriptors up above. So this is for two reasons. One is it means that a legacy player, by that I mean that one that's already in the market that only supports the 2014 profile, will reject the adaptation set because it's marked with 2017 DVB URN. And it means even one that supports the 2017 profile, but if it doesn't support HLG10, it will reject it because it won't support those essential property, the color primaries, matrix coefficients, and transfer characteristics that are defined in those essential property descriptors. So PQ10 is sort of a bit simpler. That only has essential property descriptors. It doesn't have any supplemental property descriptors because the essential property descriptors are for the BT2100 PQ system. And the MPD has to use the 2017 DVB profile, or at least on that adaptation set it has to be marked with that profile, so that the legacy devices that only support 2014, which have to be assumed not to support PQ10, will not try and play it. Because PQ10 isn't backwards compatible, it is recommended that an adaptation set with alternative video, i.e. video without PQ10 in it, should always be included, such that the legacy players, the ones that don't support PQ10, can have some video to play. Otherwise, they won't be able to play your service at all. Here's excerpts from some example MPDs, which are sort of a bit cut down and simplified, but shows the concept. So we have an adaptation set that's for HLG10, as you can tell from these essential property descriptors with these values for the color primaries, matrix coefficients, and transfer characteristics, and also as a supplemental property descriptor here. For PQ10, we only have the essential property descriptors, and these two values are actually the same, but this last one, the transfer characteristics, are different. I'm not showing actually the use of the DVB profile, the 2017 profile, but that would be there as well in this case. And also, as I mentioned, in this case, ideally there'd be a second adaptation set with some, hopefully, UHD content that doesn't have the essential property descriptors and doesn't include PQ10. So moving on to high frame rates. HFR uses the concept of temporal layers that are a feature of HBBTV. So for instance, you could have a base layer of 50 Hertz and then have a higher layer which then sort of bumps that up to 100 Hertz. A key point here is a representation must contain all the temporal layers that are needed to decode that video. So in other words, DVB-DASH does not support separate carriage of temporal layers. You can't put the base layer in one representation and the higher layer in another representation. Although you can do that, or the equivalent of that, in broadcast. The reason for that is to ensure that, or to allow the player to only ever download one video representation, doesn't have to download multiple representations, combine them, or to be able to decode the video. Each representation that's using the temporal layer, so has HFR, must include a supplemental property descriptor indicating the highest temporal ID that it carries as a helper to the player, and also the frame rate has to be marked on every representation as well, again to help the player. Next generation audio. So NGA enables audio to be split into components. And the NGA signaling in DVB-DASH allows the player to select and decode only those audio components that are signaled by the content provider to make up a collection that provides a complete user experience. So, for example, the music and effects plus dialogue also are decodable by the player, because the player doesn't want to select something it can't decode, and that are according to the user's wishes. So if the user has set English language as their default, as their preferred language, then the player only wants to get those audio, the English language dialogue, and not any other dialogues, ideally. MPEG defined a concept of pre-selections, and that is what is used to signal these collections. Players are required to support MPDs describing multiple pre-selections, but each pre-selection must be in a single representation. And DVB's defined some acronyms for the different modes that can be used. So we have SRMP, so the single representation, multiple pre-selection. So that's sort of the standard case that you'd probably come across. SRSP, single representation, single pre-selection, which is not particularly useful perhaps, but is possible. There is another one, MRMP, multiple representations, multiple pre-selections, which is defined in the specification but not required for players to support. So it's optional for them to support that one, and that is where the audio components are split across multiple representations. So the player will select the best pre-selection based upon existing criteria that it knows about, so language, the role, and for instance, clean audio or audio description. And adaptation sets are tagged with an ID, which is referenced from a pre-selection, so that once the pre-selection is chosen, the player knows which adaptation set to select to get what it wants. And then pre-selections indicate which audio components in the referenced representations are applicable. Now here's an example SRMP, that's, as you remember, and is single representation, multiple presentation MPD, which has got 3 pre-selections. So it's got a primary one, which is got the role of main, so that's what you would select by default. One which is for audio description, so audio purpose, so it's a value of role of commentary and audio purpose of 1, which means it's audio description. And then a clean audio one, which is an alternate audio with audio purpose of 2. And these pre-select, so it's got, all of them have a pre-selection components value of 1, which goes back to this. Actually, there's only a single adaptation set, so they all point back to the same adaptation set. But you've got these different tags here, 101, 102, 103, so that the player knows what to actually decode from this stream. As I mentioned in the sort of agenda of what I was going to cover, I want to just touch upon the relationship with HBBTV, because DVB and HBBTV work closely together with DASH, and HBBTV is a major customer of the DVB-DASH specification, and it's helped to make DVB-DASH in sort of quotes real in the market. It's been a requirement in HBBTV since 2015 in HBBT 2.0, which is confusingly TS102796 version 131. And HBBTV has provided input into DVB-DASH with particularly to help make this specification testable, which is one of the key things that it does, is to provide a test suite. So they have generated lots of test material to test players against, ensure interoperability in the market. And the latest HBBTV version 2.02 now references the latest DVB-DASH specification and includes requirements on HDR, HFR, and NGA. So moving on to implementing DVB-DASH, there are a few resources that people might find useful. If you want to play a DVB-DASH in MSE in your browser, then there's a dash.js mature open source JavaScript library that you can use or you can base it upon, your application upon. Just to note, their MSE cannot be used to decode audio which requires multiple representations, so receiver mix or MRMP NGA. -IF have a validation tool which can be used to check the MPD and also to a certain level the media segments, and that's been currently extended to cover DVB-DASH. And HBBTV have commissioned a DASH DRM reference application, which is it's available in GitHub now if you want to go and give it a go, and you can use it if you'd like to base your own Dash player application on. Then finally, looking to the future, the technical module is currently working on extensions for low latency live Dash to enable players to present live Dash with the same type of latencies as for DVB-T CRS delivered content. And also the technical module is working on ABR multicasting of content across the internet. Might be just a part of the journey across the internet, or could potentially be all the way to the player. And the commercial module is working on DVB-I, which aims to allow internet-delivered services to provide the same user experience on a TV as DVB-T CRS delivered services. And targeted advertising, which enables the replacement of a broadcast advert by one targeted to the TV, to the player, and delivered typically over IP, potentially using DVB-DASH. And that's the end of my presentation.
Okay, this is Peter Siebert from the project office again. Simon, thank you very much for this excellent overview about DVB-DASH. And one question came up during your presentation, and the question was, what about enhanced AC3? Do you have an answer to this?
EAC3, that is included in the profile that's in TS101154.
I'm very impressed, Simon, that you know the answer by heart. No, that was a good answer. Thank you very much. Yeah. And I'm also very impressed that we have more than 45 listeners on this call. So I think DASH is a subject which has quite some interest in the community, and I'm happy that DVB can provide additional information about our specifications. So with this, I would like to hand over to Chris Poole from the BBC. And Chris will tell us more about DVB-DASH and codecs related to it. So Chris, the audience is yours.
Okay, thank you very much. So hopefully you can see my slides. I'm sure somebody will tell me if you can't. So as Peter mentioned right at the start, really, it's important to consider the codecs that are used as well as the delivery mechanism. So we have a DVB-DASH specification that covers a lot about interoperability in terms of the delivery. I'm just going to talk a little bit about what we've done recently to sort of advance the kind of the interoperability at the sort of codec level. So just a little bit of background. I mean, DVB has addressed codec interoperability since the 1990s, originally for broadcast, and more recently addressing DASH 2. So there's a little timeline there of the different revisions of the relevant specification. And yeah, so there's a long history of doing this for broadcast, which leads to the kind of interoperability that we have today with television signals and receivers. So in this new version of the specification, published in February, it's been retitled to reflect its kind of broader nature now, covering broadband applications as well, and it includes an annex to address the use of the DVB codecs for DASH. So you might ask, why not you just use the broadcast codec profiles? Why do we need to actually do anything different here? And the answer to that is that DASH works a little bit differently. Simon's explained some of the high-level points, but just to reiterate some of the differences that affect the codec interoperability. Broadcast uses the MPEG transport stream as its system format, whereas the DVB profile of DASH uses the ISO-based media file format as used for MP4 files. We have different random access requirements. In a broadcast stream, it's about just kind of joining the service at a particular time. For DASH, there's requirements linked to bitrate switching and changing resolution and adaptation, which is a key feature there. So that also covers the third point there. We also have the case that streams delivered over the internet today target a whole range of different types of devices. It's not just televisions. There are obviously sort of TV-like devices and set-top boxes, which are very important to us within DVB, but also the content can reach mobile devices, desktop PCs, games consoles, and so on. So we need to think about wider content interoperability when we're thinking about what constraints a DVB-DASH content stream, a DVB-DASH presentation should have. And then the fact that DASH allows for kind of flexibility and offers multiple encodings to the client, primarily to select between and to cater for sort of network throughput variation. But that also gives us some advantages for interoperability, because if we have a set of representations covering different resolutions, devices can choose the ones that they support and ignore perhaps higher resolutions that they don't support. So there's a level of compatibility that comes from that you don't get in broadcast. In broadcast, you only have the single broadcast transport stream, which goes out over the air to millions of devices, and there isn't anything else to choose from. So that leads to a slightly different approach. So in the TS10154 specification on the broadcast side, there's a one-to-one mapping between specifications for bit streams, what we broadcast, and the IRDs, the integrated receiver decoders, the kind of the reference model for what a device implements. And although there's some additional backwards compatibility requirements, essentially there's a specification for a bit stream to go with each IRD definition. In Dash, we've got kind of similar concepts. We've got some bitstream requirements. We've also got some Dash player conformance points, which is the equivalent of the IRDs. But in this case, we have just one set of bitstream requirements for each video codec. And there are a number of player conformance points, but the bitstream requirements are specified as one set. So then the player conformance points support all bit streams that conform to the bitstream requirements up to specified limits. So the end result is that we have sets of player conformance points that can decode compliant bit streams and bit streams that can target a number of different player conformance points, and the player being able to choose the various representations that it can decode. So we also define the player conformance points in terms of the broadcast IRDs. So rather than just starting from a blank sheet of paper and saying Dash is a completely separate world, well, it isn't, because it's going to run on a lot of the same hardware. So by defining the player conformance points in terms of existing IRDs, we have maximum interoperability with the hardware that supports those broadcast IRDs. But there are some differences, and that covers things like the resolutions and frame rates, and also the kind of some of the constraints which broadcast has are lifted or changed in the Dash case. So let's look briefly at what the actual player conformance points are for the two video codecs referenced from DVB-DASH, ABC and HBBTV. So for ABC, it's quite straightforward, really. We've got a conformance point for 50 Hertz devices and a conformance point for 60 Hertz devices. Some devices might support both. But you can see that I've listed some example resolutions that fall within those profiles, and it extends all the way from 1080p at the top there to very low resolutions and frame rates, and those lower ones are kind of for service continuity, primarily on mobile networks and so on. But there's a very broad range of resolutions supported within those conformance points. We do also define a slightly reduced profile that limits the resolution up to the capabilities of AVC high profile level 4.0, because there's quite a lot of hardware out there that has that limitation. So those are the four AVC profiles that are defined. We haven't included any standard definition profiles. We assume that HD is the baseline, although, as you can see, lower resolutions are supported within those profiles. So for HBBTV, it gets a little bit more complicated. The HBBTV profiles, they kind of reflect the broadcast defined profiles, the IRDs, and they include all of the UHD phase 2 features. But just to kind of show them individually, we've got HD profiles again, 50 Hertz and 60 Hertz. There's an 8-bit HBBTV version as well, but the main one there is the 10-bit one. There is then a UHD profile that introduces BT 2020 color. I've not shown all of the colorimetry details on the slide because it gets quite challenging, but that's the UHD profile. Then we have two HDR profiles that extend the UHD with HLG10 on the left and PQ10 shown on the right. So two alternative HDR profiles, just as defined for broadcast. And then we have high frame rate variants, again, two versions, an HLG1 and a PQ1. So one thing that you'll note from that is that they appear as supersets. That's not by accident. The characteristics of DASH, where we have adaptation down in resolution and frame rate, means that we need to support, for example, BT2020 color at lower resolutions and so on. So there's the requirements to do adaptation to so that even if you're doing UHD HFR, you can still do lower resolutions as well. The players will support that. So finally, I'm just going to just talk through a few of the high-level features of the codec profiles for DASH. So as we've seen, there are HD, UHD, HDR, and high frame rate player conformance points defined. On the aspect ratio, we have support for 4:3 and 16:9. Aspect ratio is handled slightly differently because we're not just trying to target TV devices, which typically have a 16:9 picture these days and a fixed orientation. We might be additionally targeting laptops, which may have different shaped screens, desktop PCs, tablets that you can turn from portrait to landscape, and so on. So the way in which different shaped pictures are carried is covered slightly differently. Content can use, in theory, any aspect ratio, but the player conformance points are restricted to 4:3 and 16:9. So as you may have seen on the previous slides, we support interlace within ABC, but for HEVC, we've limited the specification to progressive only. There were no strong requirements to support interlace, and actually there's the simplicity that gives for the client implementation and indeed for the specification is quite significant. So progressive is the only option within HEVC. So we've also taken care to ensure that it is possible to construct bit streams for DVB-DASH that are also compatible with the Common Media Application Format specification from CMAF, which is relevant because a number of other classes of devices will have implementations that support media that is constrained to the CMAF specification. So one does not automatically conform to the other. There are areas where the DVB codec profile is a little more flexible and areas where the CMAF profile is a little bit more flexible, but it is possible to create a usable MPEG DASH service within the constraints of both. We've discussed HDR, HLG and PQ supported. In the case of HLG, the signaling at the sort of bitstream level is a backwards compatible form, which signals BT2020 as the primary transfer characteristics and a preferred transfer characteristics signaling to indicate that HLG is supported by the bitstream. And finally, as Simon mentioned, we can use temporal layers within HEVC bit streams, which may be of use in encoding and distributing HFR, high frame rate services, but we don't have the equivalent of the dual bit approach from broadcast. And that's it for the summary. Peter.
Okay, so it's Peter Liebert again. Chris, thank you very much. I think that was an excellent overview about codecs. And before I hand over to Martin, I would like to give a question to the panelists. And the question is, I have a problem to understand the business case. As an OTT provider, why should I use DVB-DASH instead of MPEG DASH? What is the benefit? What is the target? So the question is basically, why did DVB bother at all to do a DVB-DASH profile when already MPEG DASH exists? Who would like to answer this? Your mics are open.
I'll give it a first go, and maybe Chris or Martin can add some more. Well, as I mentioned, MPEG DASH is a big spec, and if you are targeting an embedded device with a native player, which is the case for many TVs and set-top boxes today, then it is extremely unlikely that they will have implemented the whole of MPEG, the MPEG DASH specification. Hence, that was one of the reasons why DVB has done the constraints to try and ensure that the content that you produce as an OTT provider, or the way that you signal it, is within the limits of the players that will be out in the market. The other point is about the codecs. MPEG makes no mention about the codecs that are to be used. So you would be assume so if you had some ABC content, for instance, you wouldn't know how to encode your content, even though you're using ABC. What resolution to use, what frame rates, what anything. So DVB again provides some guidance, some rules on how to encode it and what the player that's supporting ABC has to support. So it's just the usual thing, to be honest, of MPEG producing a big specification, which is fine, which will satisfy everybody, but DVB trying to constrain it to something that's practical and implementable by players and usable by content providers, so that you've got far more confidence that the content you produce will be consumable by these devices. Chris, I don't know if you want to add anything.
Yeah, that's the main point. Yeah, it's all about interoperability. I mean, in some cases, there's additional things in DVB-DASH to cover specific use cases that come from kind of the broadcast world, but principally it's interoperability.
Okay, thank you very much, Simon. Another question came up, and I would like to give this question to Martin, as he's anyway our next speaker. So the question is, what is the difference between DVB-DASH and CMAF?
Yeah, Martin here. Hi. I think I will come to the CMAF part already in a few slides, but CMAF is more about defining a basic constraint media packaging and segment format, which can be used in both worlds, for example, in the iOS Apple world, together with the HLS manifest, as well as maybe in the HBBTV world, where we can benefit from the DVB-DASH specification as well. But CMAF does not cover any piece of the manifest, for example. So there is not the manifest format is completely out of scope in the common media application format. So both we hope both specifications can work together, and we can set up an interoperable service to be able to encode once and distribute to multiple platforms, including the Dash world on the one hand and the iOS Apple world on the other hand. I don't know if this answers the question precisely.
I think it's a fair summary, Martin. Thank you very much for pointing this out. And in the end, it's basically about the efficiency to have the content only available in one format and not in different formats for the different flavors of DASH. So this brings us now to your presentation, DASH in the Wild, as you have called it. I must say, Martin, I like the title. It sounds like Wild West. And basically, you will answer now the important question to which extent DASH is used and which flavors of DASH are the predominant ones. So please go ahead with your presentation.
Thank you very much, Peter. I will try my best. I don't know if Germany is that wild, but we will see. First, maybe some numbers which could be interesting for some participants. So, although they are specifically from Germany, we see here the usage, the overall usage of different streaming services, including the public broadcasters in Germany. And there, when you look, I don't know if you can see my mouse cursor, if you look in the section from 14 to 29 years old people, there we have had in 2017 the first time more users for VOD than for when watching linear television. And this brings us, of course, to OTT, so that we need to prepare to a future where we have a lot of more OTT usage. You can see this also in this red line, which is indicating the summarized traffic over the last years from the public service broadcasters in Germany. So there's still a lot of growing traffic, which produces significant costs, of course. And when we have a more technical view, I put up some of the last market shares here for you. What I want to highlight here is specifically the different versions of HBBTV in this right block here, from beginning from 1.0 until 2.0.1, which we had in the end of 2017. And there I want to highlight that we already in Germany have this year already a lot more than 50% of all connected smart TV devices supporting MPEG DASH, basically with the 1.5 HBBTV specification. Although DVB-DASH is only mandated in beginning from 2.0 HBBTV, you can already benefit from providing DVB-DASH compliant services already also to a lot of HBBTV 1.5 receivers out in the market. So and these numbers are improving currently. When it comes to test cases, we already had our first UHD live stream in 2016, provided together with the Arte broadcaster with a live production in the Opera of Vienna, where we had an Ateme DASH live encoder available at IRT, and this was provided to HBBTV 1.5 to a selected range of models, because as you might know, 1.5 does not mandate UHD support, but some devices already did support it practically at the time. Now we had just recently, together with DVB and the DVB World event, we demonstrated streaming with UHD HDR in the HLG variant on a smart TV device using an HBBTV application. You see some of the details here, which hopefully should fit well to the DVB-DASH specification. So you see, you can already do this, also using, for example, a well-known CDN like Akamai. So you can already provide services for customers today. Then coming to, let's say, some kind of regular DASH live streaming in a regular service in Germany that was started, let's say, with the introduction of DVB-T2. So when DVB-T2 was rolled out in Germany, some broadcasters felt they would like to add some more live channels for which they have no terrestrial spectrum available. And they did this, they have been going for HBBTV 1.5 in this case, because it mandates a basic version of DASH, which mostly is a subset of DVB-DASH. Unfortunately, not completely fits in, but mostly. And the idea was to provide additional live streams to the TV users, which appear to them just like a regular DVB broadcast service. And you can do that now. So if you put your antenna out of the window and receive your DVB-T2 signal, then you will get additional channels which are marked as internet channels, and these are MPEG DASH live streams following the HBBTV 1.5 specification. So now I need to speed up because I was supposed to finish at 10 after. Maybe we speed up a little bit. You can have a detailed view on the slides afterwards because they are prepared and presented to you also in the recording. So if you want to know about the details, these are the resolutions and bit rates we have been going for this so-called Internet Link Service, ILS, with DVB-T2, as I said. There is one thing which was also included. It is called Direct Dash Play. This is a little bit different from what we have been using in the ILS service. It was introduced by Freenet TV. Why is it different? Because here the manifest link to the MPD, as you can see in the screenshot, is not requested with the HBBTV application, so via the HTML or the JavaScript. Rather than it is directly inserted into the broadcast MPEG-2 transport stream, which gives you, which is supposed to give you lower channel change times and faster playback, but has some other drawbacks, of course. Finally, coming to the HBBTV specification, which is referencing to DVB-DASH from the 2.0 on, you see here some restrictions in terms of bit rates, which can be different when you use HTTPS or when you use plain HTTP, and there are even less codecs to be supported mandatorily by HBBTV. We already also heard about which is in terms of switching, bitrate switching, which needs to be supported and which not from the DVB-DASH specification. So there is also a little bit of difference between HBBTV 1.5 and 2.0 with DVB-DASH, which you can see here what is mandated and what is not from the receiver side. Yeah, this is only an overview of the interoperability testing we currently prepare at IRT. So you are supposed to access streams for all these formats in the near future. Finally, this is I call it cheat sheet what we use when we are testing devices manually using DASH streams, for example. Can look like this. If anybody is interested in, I can provide the Excel sheet. We also have a test center at IRT where we can do automated testing of HBBTV applications, of course, including DASH streams. And we did already, we do regular testings at the interoperability workshops at IRT, taking place every 3 months in Munich, and these are the outcomes of my latest test results, testing HDR, especially HLG flavor on various devices, even on 1.5 HBBTV devices, which not explicitly support HDR, so they are decoding the backwards compatible part quite fine. Okay, I think I have to go quickly about this slide is only about the common media application format, about the benefits of having one segment which can be used on iOS, PC, and HBBTV in comparison with different manifests. Yeah, this is maybe the overview of our findings when it comes to the CMAF interoperability. So we didn't find any issues with basic services. So it was possible to have one segment and play it on any HBBTV device with 1.5 ongoing, including iOS 10 plus with another manifest. And if you want to test a little bit your own environment, you can go to avtest.irt.de, where we provide a lot of test streams which are freely available also for download, including non-adaptive and adaptive, and where you should be able to find also HDR tests soon. And this is now my last slide. We also have a so-called adaptive streaming seminar, including MPEG DASH at IRT in English language. Next one will be on the 10th and 11th July. So we still have 3 places available. And so there we have 2 days discussing really in depth about all the adaptive stuff, and also doing some code review and some hands-on experience. So if you are interested, just go to the IRT website. And I think I'm a little bit late, but I tried to go for 10. So that's it from my part. Thank you very much.
Good. Okay, Project Office again. Martin, thank you very much. I think that was a very nice wrap-up of the 2 presentations we heard before, including some very relevant information about the status of DVB-DASH in Germany, and I think Germany may be also representative for other European countries. So, and I think it's no problem that it took a little bit longer than expected, because the information provided by all 3 presenters has been very relevant and I think important for the audience. And again, I have good news to share. Most of the audience has stayed with us, even when we are way over time. So also my thank you to the audience for being interested and for being patient. So again, thank you to the panelists, thank you to the audience, thank you to Owen, who was essential in setting this up and helping me. And finally, I want to announce the next webinar. And the next webinar will take place on July 3rd. And from DASH, we go to a satellite terrestrial distribution subject. The next webinar is on single illumination. So basically, how to bring content over satellite on the one side direct to home, to the end user, and on the other side, with the same signal, feeding a terrestrial distribution network. And this will be presented by Frank Herrmann and Jean-Pierre Mossé. And I hope that all of you will participate at this webinar again. And I see there's one question. The question is, will it be possible to replay these webinars? And the answer is yes, it is possible. And you just have to look at the URL you see on the screen right now, dvb.org/webinars. And there you will find the information, the recording of all our webinars, and in the future also of all upcoming webinars. And so I think this ends the seminar. I have already thanked everybody. So dear colleagues, I wish you a good rest of the day. And I'm looking forward to the next webinar, and I hope that some or most of you will participate again. Thank you very much, and goodbye.